Welcome to the video from Chapter 5, Triangles and Congruence, Lesson 3, about geometry in motion. We're going to answer the question, in what ways can we move objects on a plane? Starting with some vocabulary, the definition of isometry is movement that does not change the size or shape of an object. When one image, in this case triangle ABC, is simply slid somewhere, up, down, left, right, it doesn't matter, it's just like, imagine it sliding down the page here, and we have triangle ABC turns into this A with this little mark, B with this little mark, the apostrophe up there. This is called A prime, and B prime, and C prime. So that little apostrophe there is actually pronounced as the word prime. So we use that to signify that it's the second one. So this is the original triangle ABC, and when we just move it down and create A prime, B prime, C prime, so we still have that original triangle over there, we've just pretty much copied it and slid it down. This sort of isometry is called a translation. So again, it's a translation when an image is simply copied and slid somewhere. You get the exact same image, but because it is a new image, we use this A prime, B prime, C prime. You just prime whatever letters are originally in the image. In this example, I want to start talking about the other use for these primes is that you can see which one was the original image and how it changes to the new image. So RST is our original triangle, and now we have this R prime, S prime, T prime, and if you notice, it looks like this could be a right angle over here on the left-hand side, but then we come over here and it's on the right-hand side. So this dashed line acts as a sort of line of symmetry. It's actually more of a reflection line. Think of an image in a pool. This was kind of flipped over to this one. It's called a reflection. So the reflection is an example of isometry where there's this line, this reflection line, and something just kind of gets flipped over it. The final type of isometry that we're going to be dealing with in this lesson is that of rotation. And so with rotation, there's some sort of arrow that may be indicating which way it has turned, and there should be somewhere like a point of rotation. So it's like this, there's like a line here between the point and E that would then rotate it onto the point, the E prime. So just imagine that there's this point that the image, that the original image, in this case triangle DEF, is rotating around to get the D prime, E prime, F prime triangle. So now, given these three choices of translation, reflection, or rotation, go ahead and take like 20 seconds, write down what you believe each of these are. So try to follow those arrows if you can. So this quadrilateral is being transformed into this one. We have, I guess, like a left to a right, or either a right to a left. In this case, it doesn't matter. There's an arrow indicating this one kind of moves up here, and then this one has that arrow there. So identifying between translation, reflection, or rotation. Pause the video, write down your guesses, and then we'll check answers. All right, so in these four problems, we have two rotations. A and D were rotated pre-images onto the image, so rotations for A and D, a reflection about this dashed line of this lightning bolt, and then this quote looking bubble thing was just slid upwards, so this is a translation. So in this next set of problems, you're asked to draw each isometry. So you're just going to do the best that you can by hand. If you are given problems where you have the ability to make adjustments online, so for example, like what I'm going to do with this reflection is I'm going to copy this, it looks like the letter P here. So I've copied it, and then what I can do is I can use my tools in this particular program and I can flip it. And you'll have that ability to do that in other, Google Draw or other sort of programs that you might, if you have that option available to you, then I would suggest using it. So that would be a reflection. So notice that I didn't keep it as a P with the, the straight line, with the straight line going here and then the bump out on the top. I didn't keep that to the right. I had to reflect it, so it needed to be then pointing to the left. So that's my example for a reflection. So a translation, remember, it just slides. So I'm going to draw this trapezoid, and I'm going to try to get it. It really has to be the same size. Remember, that's what makes it isometric, is that it's not changing size or the shape is staying a trapezoid. So that would be my best ability to draw that. I can't seem to get this particular image to copy nicely to slide. So just like on your paper, go ahead and draw your translation as the best you can. The rotations are a little bit tricky, but again, you just kind of imagine that there's this point out here somewhere that's making you do this flip. So I'm going to grab this. I already went ahead and made a copy of it, and I'm just going to rotate it. It's going to turn about that point. You can see I'm trying to get, getting larger and smaller. I'm going to try to keep it that exact same size. And what I'm doing here is what you need to be doing visually, like in your head, to try to picture what object is going to be created next. So I did not just take this and slide it. I didn't flip it completely upside down because I am just doing a simple rotation here, but even flipping it completely upside down may not necessarily be wrong. Just try to keep it that same size. So there's my rotation. So again, for another rotation, you just want to be careful that you're not just sliding it in this direction because it is identified as a rotation. So that arrow does not mean that we're just translating it. This one needs to be rotated. So again, imagine that there's some dot out here that's like keeping this, I don't know, together. So when I rotate it, it has to be like connected to that dot, or at least to the end of the red line, so it can be out a little further, and then that would be my rotation. Taking a look at a last little bit of vocabulary here is this concept of mapping. A mapping is a one-to-one correspondence pairing each point on the pre-image with exactly one point on the image. So this original image we call a pre-image, and then what after the transformation, after that isometric move, we get the image. And actually calling it a transformation jumps ahead to where what goes in this blank down here at the bottom. Mapping a pre-image to an image is called a transformation. So let's go ahead and fill that part in down there. It's at the bottom of your page, I believe. So it's a transformation, and the transformation refers to all three of the translation, rotation, reflection, and actually there's even more of them, but these are the three where the size and shape do not change. Either way, in this example, we just map directly from the pre-image to the image, and we'll use that to name some pieces here. So using that the concept of mapping, the image of AB. So AB is the pre-image. The image of that would be the line XY, or the segment XY. So we'll put that segment over there. The pre-image is what we're looking for here, the pre-image of angle X. Well, angle X is here. The pre-image of that, so you're like working backwards, would be angle A. And then last one, the vertex that corresponds to B. So vertex is just a point, so it's not an angle. We're just referring to that point of intersection. The point that corresponds to that would be Y. And so since it is a vertex, it is just getting the letter, no symbol goes with that. And that's it. This concludes Lesson 3, Geometry in Motion. So what ways can we move objects on a plane? We can slide them by translating, flipping them by reflecting, and turn them by rotating, keeping in mind that this all references transformations, which just refers to those three types in general.